Hello, my name is Saikir Naka, and this is my video submission for homework number 1. So first, here I have the Verilog code for the XYZ function, and this is basically just the code from slide 23 of the presentation. So here we have the module, and the input and outputs have been declared, and here we declare wire t, and then we use the Verilog syntax to assign values to these variables using the symbols for the logical operations. I then translated this code to VHDL. So here we have the necessary inputs, or rather imports. And instead, since VHDL uses entity and architecture instead of module, I have entity XYZ. And here I declared the ports. So A, B, and O_E is are bits that are in. And here I have XZ as out. And then I have Y as a bidirectional bit. And the reason I have it like this is because in line 46, we have Y on the right side of the assignment operator, and with this operator, you can't use out bits on the right side, and that's why I made this bidirectional. But here in the architecture, I declared wire T, and then it's just the same code from the Verilog, except I use the VHDL syntax to assign values to the variables, and I use the long form of the symbols because that's just how the syntax for VHDL is. And then we have the simulation. And so in this simulation, once it opens, the way I did this was I basically went through and just forced the constant for all the different permutations of the inputs, like so, and I would run it and then change it like so, and then I would keep going. So after this, this would be 0, etc. And so I already did it out here. And so eventually, when I go and do all the different permutations of inputs, we get these outputs, and obviously here it's all 0 because the enable is at logic low. And this was the way that I simulated the circuit, and both circuits behave the same because they're logically equivalent.